guys, welcome back. Today let us discuss the adjacency matrix. Adjacency matrix. Let graph G equals set of vertex on the edges, right? Then number of vertices is n and number of edges equals m. The adjacency matrix of G is written as written as sorry, not A of A, written as A of G is the n by n matrix, in which entry is Aij is the number of edges in G with endpoints Vi, Vj. Okay, so this is the definition of a adjacency matrix. So don't worry about the definition. Let me explain. It will be very easy for you. So let me draw a sample of the graph. Okay, so I'm just drawing the sample. Any shape on any number of vertices you can take. For example, I draw this graph. The vertices are w, x, y, and z, and the edges are a, b, c, d, and e. So always remember the adjacency matrix is drawn between vertex to vertex. Always remember adjacency matrix is a matrix between vertex to vertex. So here, so we need to draw the matrix. This is the matrix. Okay, right? So what is it? It is a vertex to vertex, right? How many vertices we have? W, X, Y, and Z, right? So W, X, Y, and Z. And here also on the top, the row also WX or vertex, and the column also the vertex, right? Now, if anything is adjacent to each other, then we need to mark as a 1, otherwise null. For example, W, success is a W is adjacent to W? No vertices are adjacent to the same, so it is 0. W is adjacent to X? Yes, so W is directly linked to X, so that is the one is given here. It is the endpoints. It is the endpoints. So it is given clearly. It is the endpoint, right? So W and X are the adjacent vertex. That means if any vertex had direct link to another, suppose this A and B, we can say A is adjacent to B. So similarly, W is adjacent to X. So 1. Also, W is adjacent to Y. There is a direct link between W and Y, and W is not adjacent to Z. So 0. Similarly, X is adjacent to W. Yes, X is adjacent to W, and X is not adjacent to X, and the X and Y. So here, if you see the X having two two edges connecting to Y. So this is 1 and this is 2. So That means we have two two vertices, I mean two edges or connected, or the endpoints, two edges or the endpoints of the, sorry, x on y are the endpoints of two edges. So two, meaning there exists two direct link between x and y. And then 0, there's no link between x and z. And y and w, we have 1, and we have a 2 again. The y and the x, that exists two direct link, that is two edges exist. So 0 1, likewise we need to find the adjacency. So whatever, so this is the adjacency matrix. This is the adjacency matrix, right? Very easy, very simple. And then after adjacency, what we can have, we can have the insert. So you can try for any other example. For example, let me try another example. Another graph I have, say like this. I have the graph of anything. I have like this, any graph. So this is a b c d e f, and I have the edges. I mark the edges in a different way, so we are not concerned with the edges. Say edge 1 2 3 4 5 6. Now we need to draw the adjacency matrix. So the adjacent matrix is the matrix drawn between vertex to vertex. How many vertex we have? A, B, C, D, E, and F. Okay, and column wise A, B, C, D, E, and F. Now A is adjacent to A? No. A is adjacent to B? Yes. A is adjacent to C? No. A is adjacent to D? No. A is adjacent to E? Yes. A is adjacent to F? No. Now come for the B. So B have direct link between A and C. So B have direct link between A and C. The rest is 0. And come to C. C having direct link between B and D. C have link between D and B. So the rest is 0. Clear? Very easy. And then D. D have a direct link between C with C and E. D have link with C and E. The rest, the D has no direct path or direct link. And then E has link with the D and the A. E, A and the D, the rest is not having the link. F having only one link with the E. F having only one link with the E. The rest is 0. Right? So this is how we, sorry, here is one, because we have link, 3 links. We have link with the A and A, D and F. So 1, that is 0. So this is the adjacency matrix. So this is one way of representing the graph in a linear form or in a array form. Clear, guys? Then next topic is incident matrix. Incident matrix. So incident matrix, again, see here, very simple incident matrix. Again, I take the same example. Here we have this W, X, Y, and Z. Here we are, I draw in the edges in a different color, A, B, C, D, and E. So here, keep in mind the incident matrix is a matrix drawn between It's a matrix between it's a matrix between vertex to edges. Okay, so previously the adjacency is the matrix between vertex to vertex, incidence is a matrix between vertex to edges. So what we need to do here, into how many vertex we have, w, x, y, and z, and how many edges we have, a, b, c, d, e. Okay, now now if any vertex is incident to any edges, make it 1, otherwise 0. For example, take w. In w, how many edges or incidents, how many incident we have, I'm marking different color, we have a is one incident and b is another incident. That means in w, a, yes, I mean a is the incident of w, so make it 1. After that, b also incident to w, make it 1. But c, d, e not related to w, so 0. Then comes to x, so a, c, and d. For x, a is incident, c is incident, d is incident, b is not incident to x, and also e is not incident to x. Then y having b, c, d, e, y having, so a is not incident, the rest b, c, d, e are the incident. That means what is incident? If any vertex is connected to any edges, okay, then we can say e is incident to vertex v. Okay, that's incident means what? Any edge is connected with the vertex, then it is called the incident. So if you see z, only e is connected, with z, so that is e is incident with the z. 0 0 0 0, and this is the e. Okay guys, so these two matrices are very easy. So repeating once again, what is adjacency matrix? Adjacency matrix is a matrix drawn between vertex to vertex, and incident matrix is drawn between vertex to edges. Okay, these are the two things you need to remember. Very easy. Okay, right? See you. Bye bye. Have a great day.